Welcome to lesson 4.7, emotion problems. We're going to solve those using algebraic equations. So first thing, when we talk about velocity or speed, right, that's another way we might think about it. If you picture driving in a car and you see a speed limit on the side of the road, the speed limit on the highway, for example, might be 100 kilometers per hour. So if you ever forget what the equation is for speed, we know that speed could be in kilometers per hour. The other way of thinking about it, kilometers is really measuring a distance, and hours is really measuring a time. So if you can remember a speed limit, you can remember the formula for speed. So another way of writing it is to write, we can multiply both sides by the speed, and we can write that speed times time equals distance. And this is going to be the form I use more often when I'm solving things. Speed times time equals distance. So steps for solving motion problems, you can read them, but number 2, using that chart to organize data. I love organizing data for these ones in charts, but I'm also going to be drawing pictures for a lot of them. So if we look at question 1, 2 trucks leave Buck's truck traveling in opposite directions. One truck traveled at a rate of 70 kilometers, the other at 80 kilometers an hour. After how many hours were the trucks 900 kilometers apart? So we've got Buck's truck, it's here in the middle. And we're going to have one truck travels at 70 kilometers per hour. That's our slow truck. How do I know it's slow? Because the other one's going faster. This one is going 80 kilometers per hour. So that's going to be our fast one. After how many hours were the trucks? So we're going to be solving. After how many hours means we're going to be solving for time. And we know that after all that time, the trucks are 900 kilometers apart. So if we were to look at the total distance, we don't know how long they've gone, but we know that they are 900 kilometers apart at the end. So here's how I would build this in a table. I would have speed, time, and distance. I would have my fast and my slow in this case. We know that the speed of the fast truck is 80 kilometers an hour. The speed of the slow truck is 70. We don't know how long they traveled for. That's what we're solving for. So we're going to let x be time, and they're both x because they both traveled the same amount of time. They left at the same time, and then they get measured when they're 900 kilometers apart, so they've been driving the same time. Speed times time equals distance means that I would get 80x and 70x, and overall I know my total distance is 900 kilometers. So similar to the money problems, we know that the total distance of the fast car, so 80x plus the total distance of the slow car, 70x, equals 900. So collect like terms. I've got an 80x and a plus 70x. So 150x equals 900, and 900 divided by 150 equals 6. And if we're thinking about units, everything was in kilometers and hours, so this x is going to be 6 hours. And it asked in words, so we'll end in words. After how many hours were the trucks 900 kilometers apart? So the trucks were 900 km apart after 6 hours. And you can always double check. So 6 times 80 equals 480, and 6 times 70 equals 420, and 480 plus 420, hey, it equals 900, so we know that we were right. A jet flew from Toronto to Phoenix at 900 kilometers an hour. Due to strong headwind, the return trip was made at 600 kilometers an hour. The round trip takes 7.5 hours, blah, blah. Okay, so we're going to be determining the distance from Toronto to Phoenix. And they tell us a couple things, and we're going to be able to fill in our speed, time, distance table. So the first one, we have Toronto to Phoenix, and then coming back is Phoenix to Toronto. So the jet flies from Toronto to Phoenix at a speed of 900. On the return trip, the speed is 600. So we had the first way it was 900, the second way it was 600. We know that overall the total trip is 7.5 hours. So I'm going to let one be x, doesn't matter which one, and it means the other one is going to be 7.5 minus x. And we know that speed times time equals distance, so we get 900x, and we get 600 times 7.5 minus x. They don't tell us the overall distance. That's what we're going to be finding out. However, if we have Toronto and we have Phoenix, what do we know about the distance from Toronto to Phoenix and then the distance from Phoenix to Toronto? I hope you can see that those distances are going to be the same. So the distance from Toronto to Phoenix, which is, I'm going to highlight in blue, that distance has to be the same as this distance, because the distances have to be equal. So that means 900x equals 600 bracket 7.5 minus x. We're going to distribute the 600. So 600 times 7.5 is going to give 4500 minus 600x. I'm going to bring all my x's to one side, so the minus 600 to the other side. So I'll get 900x plus 600x equals 4500, or 1500x equals 4500. Divide both sides by 1500, and we get that x equals 3. And x was time, so x is going to be 3 hours. And if we look at what they were asking for us to solve, they didn't ask us to find out how long. They asked us to find how far. And if you see that how far, that's asking for a distance. So they're asking for the distance between Toronto and Phoenix. So we can do 900 times x, which would be 2700 because x equals 3. Or we could do 600 times 7.5 minus 3, which would be 600 times 4.5, which also works out to 2700. So whichever way we do it, it's going to be 2700 kilometers. So therefore, it is 2700 kilometers from Toronto to Phoenix. Two cyclists leave the same point at the same time, travel in the same direction. Okay, so this time they leave the same place at the same time, and they're traveling in the same direction. So we're going to have our slow person is going 12 kilometers an hour, and then our fast person is going to get farther. I hope that makes sense. They're going faster, so they're going to get farther. And the question is asking in how many hours, so we're solving for time, are they going to be a total of 27 kilometers apart? A total of 27 kilometers apart, that's like talking about a difference. The difference in their distances, and just for down the road, the difference means we're going to be subtracting. So, speed times distance for the slow and the fast. We know that the slow person is going 12 kilometers an hour. The fast is going 18. We know that they travel the same length of time, so both of these are going to be x. Speed times time equals distance, so 12x and 18x. And then going back to what we said, that the difference in the distances is going to be 27. That means when I subtract the two of them, I'm going to get 27. So that means that fast distance minus slow equals 27. So 18x minus 12x equals 27. That gives me 6. So 6x equals 27. And if I divide both sides by 6, I get 4.5. And the units for time, because x was time, is going to be hours. So therefore, the cyclists will be 27 kilometers apart after 4.5 hours. Question 4. 2 trains started at the same station at the same time but travel in opposite directions. If one train traveled 30 kilometers faster than the other one, determine the speed of each train if they were 675 kilometers apart after 2.5 hours. Okay, I'm going to draw a picture. Same station, going in opposite directions. So one is going to be slow. We don't know how fast his speed, so we're going to call it x. And then we got the fast one. We know he's faster because it said he was 30 kilometers an hour faster. So it's going to be the slow speed plus 30. And then they're telling us how long. They're giving us the time. They're telling us that it's 2.5 hours. And they're telling us what the total distance apart is going to be. So we're going to use all this. Speed, time, distance for the slow and the fast. The speed of the slow, we don't know. It's x. The speed of the fast is x plus 30. Time, they gave it to us. It was 2.5 hours. And then we don't know anything, but we do know that the total distance is going to be 675. So we're going to go back to speed times time equals distance. That's going to give me 2.5x for the slow, and then 2.5 times x plus 30 for the fast. And we're going to build our formula from here. So the total distance that the slow goes plus the total distance that the fast goes equals 675. So 2.5x plus 2.5x plus 30 equals 675. I'm going to distribute, so I get 2.5x plus 30 times 2.5 is 75. I'm going to combine like terms, and I'm going to bring this 75 over to the other side. So I'm combining this like term and this like term. So I get that 5x equals 675 minus 75. And I've written really big. So that would give me 5x equals 600. Divide both sides by 5. X equals 600 divided by 5 gives me 120. We were solving this time for the speed, so that's going to be 120 kilometers an hour. They asked us to find the speed of each train. So therefore, the speed of the slow train is 120 kilometers per hour, and the fast train is, the fast train was over here, x plus 30, so that's going to be 120 plus 30, so that's going to be 150, so 150 kilometers per hour. Okay, question 5. Pakari left Thornhill on her bike at noon and rode at an average of 16 kilometers an hour. Taruka left Thornhill excuse me, at 1:30 in his van and overtook Pakari after 30 minutes. So right away I'm noticing that we've got some times. We've got noon, which is really 12 o'clock. We've got 30 minutes. Everything else was in hours. So I'm going to change that into 0.5 hours. And I haven't even read the question, but like, what are they asking? They're asking us how fast was Taruka traveling. So we're going to be solving for a speed. So they both left home Picari leaves at noon, so 12:00. This is Picari, and her speed is 16 kilometers an hour. Okay. Taruka leaves at 1:30 in a van, and we don't know how fast he's going, but we do know he catches up. And the reason that's important is because when they catch up, they will have gone the same distance. So let's fill in what we knew. We've got speed and time and distance, and we're looking at Picari and Taruka. So Picari's speed is 16. Taruka, we don't know. His speed is X. Time. We know that Taruka only traveled for 30 minutes. Taruka leaves at 1:30 and catches up to Picari in 30 minutes. So that means that he only traveled for 0.5 hours. But leaving at 1:30, and then I'm going back to this picture, leaving at 1:30 and then traveling for 30 minutes means that the time that they all meet up, where they've gone the same difference when Taruka catches up to Picari, that means Picari had traveled for 2 hours. So I'm putting that in my table as well. Speed times time equals distance. So that means for Picari, speed times time is 16 times 2, which happens to equal 32. So that's the total distance. We now know the total distance that they both traveled. We know that this gone the same distance is 32, and it's going to be 32 kilometers. So now if we want to figure it out, we know that 32 kilometers is going to equal 0.5x. We get that because it's x times 0.5. So if we're solving for x, divide both sides by 0.5, and we would get that 64 kilometers is going to equal Taruka's speed, and speed is going to be in kilometers per hour. So we have now Taruka's speed, and we can answer, therefore, Taruka was traveling 64 kilometers per hour. And that's it. Thanks for watching.